Hello and welcome to Shorts in Psychology. Today we will continue in the Altered States of Awareness topic series looking at stress. What causes stress and how does our body respond in both the short and long term? We will also examine the General Adaptation Syndrome stress model and apply all of this to a past exam question. So let's begin. Stress is a biological and psychological response experienced on encountering a threat that we feel we do not have the resources to deal with. A stressor is the stimulus or threat that causes stress and could be something environmental, such as a looming work deadline, moving house, or divorce, or it could be psychological, such as persistent worry about losing a job. Regardless of what the stressful situation is, it can trigger a cascade of stress hormones that produce well-orchestrated physiological changes. A stressful incident can make the heart pound and breathing quicken, muscles tense, and beads of sweat appear. Stress isn't always bad, particularly when it's experienced temporarily. Sometimes it enhances our performance. Everyday experiences, such as the first day of school and getting a vaccine, are positive types of stress that are a normal and essential part of healthy development. The loss of a loved one or a broken bone are more severe stresses that will result in a tolerable amount of stress, but as it is limited in duration, the body is able to return to a stage of physiological calmness once the threat is gone. However, experiencing a strong, frequent, or prolonged adversity, such as physical or emotional abuse, will result in a toxic level of stress that impacts the individual's long-term health and well-being. This is because the body stays activated or aroused due to the prolonged or frequent exposure to the stressor. The combination of reactions to stress is also known as the fight or flight response because it evolved as a survival mechanism, enabling people and other mammals to react quickly to life-threatening situations. The carefully orchestrated yet near instantaneous sequence of hormonal changes and physiological responses helps someone to fight the threat off or flee to safety. Unfortunately, the body can also overreact to stresses that are not life-threatening, such as traffic jams, work pressure, and family difficulties. The stress response begins in the brain. When someone confronts an oncoming car or other danger, sensory information is sent to the amygdala, an area of the brain that contributes to emotional processing. The amygdala interprets the image and sounds. When it perceives danger, it instantly sends a distress signal to the hypothalamus. The hypothalamus is a bit like a command center. This area of the brain communicates with the rest of the body through the autonomic nervous system, which controls such involuntary body functions as breathing, blood pressure, heartbeat, and the dilation or constriction of key blood vessels and small airways in the lungs called bronchioles. The autonomic nervous system has two components, the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system functions like a gas pedal in a car. It triggers the fight or flight response, providing the body with a burst of energy so that it can respond to perceived dangers. The parasympathetic nervous system acts like a brake. It promotes the rest and digest response that calms the body down after the danger has passed. After the amygdala sends a distress signal, the hypothalamus activates the sympathetic nervous system by sending signals through the autonomic nerves to the adrenal glands. These glands respond by pumping the hormone adrenaline into the bloodstream. As adrenaline circulates through the body, it brings on a number of physiological changes. The heart beats faster than normal, pushing blood to the muscles, heart, and other vital organs. Pulse rate and blood pressure go up. The person undergoing these changes also starts to breathe more rapidly. Small airways in the lungs open wide. This way, the lungs can take in as much oxygen as possible with each breath. Extra oxygen is sent to the brain, increasing alertness. Sight, hearing, and other senses become sharper. Meanwhile, adrenaline triggers the release of blood sugar, glucose, and fats from temporary storage sites in the body. These nutrients flood into the bloodstream, supplying energy to all parts of the body. All of these changes happen so quickly that people aren't even aware of them. In fact, the wiring is so efficient that the amygdala and hypothalamus start this cascade even before the brain's visual centers have had a chance to fully process what is happening. That's why people are able to jump out of the path of an oncoming car even before they think about what they are doing. As the initial surge of adrenaline subsides, the hypothalamus activates the second component of the stress response system, known as the HPA axis. This network consists of the hypothalamus, the pituitary gland, and the adrenal glands. The HPA axis relies on a series of hormonal signals to keep the sympathetic nervous system, the gas pedal, pressed down. If the brain continues to perceive something as dangerous, the hypothalamus releases corticotrophin-releasing hormone, CRH, which travels to the pituitary gland, triggering the release of adrenocorticotropic hormone, ACTH. This hormone travels to the adrenal glands, prompting them to release cortisol. The body thus stays revved up and on high alert. When the threat passes, cortisol levels fall. The parasympathetic nervous system, the brake, then dampens the stress response. In 1936, Hans Selye created the stress model General Adaptation Syndrome, which thoroughly explains the stress response and how aging and disease are caused by chronic exposure to stress. Whilst conducting experiments relating to hormone production, Selye noticed that his subjects showed a similar set of side effects regardless of the type of life-threatening stimulus that researchers presented to them. Selye termed this collection of responses General Adaptation Syndrome. A three-stage set of physiological processes which prepare or adapt the body for danger so that we stand a better chance of surviving it compared to if we remain passively relaxed when faced with a threat. These distinct stages are the initial alarm reaction stage, which occurs shortly after the stressful event, followed by a resistance stage during which the body's autonomic nervous system resists the impact of the stressful stimulus, and finally, if the stress continues, the exhaustion stage, when the body fails to cope with the distressing stimulus. Let's look at each of these stages in more detail. In the first phase, alarm, the body mobilizes to confront the threat by activating the fight or flight response, which temporarily expends resources and lowers resistance. Your heart rate increases, your adrenal glands release cortisol, and you receive a boost of adrenaline, which increases energy. In the resistance phase, the body is actively confronting the threat and resistance is high. After the initial shock of a stressful event and having a fight or flight response, the body begins to repair itself. It releases a lower amount of cortisol and your heart rate and blood pressure begin to normalize. Although your body enters this recovery phase, it remains on high alert for a while. If you overcome the stress and the situation is no longer an issue, your body continues to repair itself until your hormone levels, heart rate, and blood pressure reach a pre-stress state. However, if you don't resolve the stress and your body remains on high alert, it eventually adapts and learns how to live with a higher stress level. In this stage, the body goes through changes that you're unaware of in an attempt to cope with stress. Your body continues to secrete the stress hormone and your blood pressure remains elevated. You may think you're managing stress well, but your body's physical response tells a different story. If the resistance stage continues for too long of a period without pauses to offset the effects of stress, the body moves into exhaustion. The body starts to lose its ability to combat the stresses and reduce their harmful impact because the adaptive energy is all drained out. The exhaustion stage can be referred to as the gate towards burnout or stress overload, which can lead to health problems if not resolved immediately. Signs of exhaustion include fatigue, burnout, depression, anxiety, and decreased stress tolerance. The physical effects of this stage also weaken your immune system and put you at risk for stress-related illness. This includes an increased risk of stroke and heart attack due to increased blood pressure and damaged blood vessels due to persistent surges of adrenaline. Now that we've examined the stress response in detail, let's apply it to a past exam question. Pause the video while you answer the question. In the first part of this question, you need to state a symptom of stress relating to the biological level of explanation. This means you need to state a physiological symptom, not a psychological one, such as poor concentration and memory or irritability, as these would fall under the basic processes level of explanation. There are many physiological symptoms you could state here, including accelerated heart rate, heart palpitations, chest pain, feeling dizzy, headaches, release of hormones such as cortisol and adrenaline, sweating, numb or tingling sensations, and shortness of breath, just to name a few. For the second part of this question, you need two well-made points about how stress will affect Shakira's health if it continues in the long term. Therefore, you need to discuss aspects of the exhaustion stage of the general adaptation syndrome model, or prolonged activation of the fight or flight response. At this point, the constant state of alert has depleted the body's resources. This can result in a range of detrimental health effects, including an impaired immune system, high blood pressure, possible heart disease, anxiety and depression, stomach ulcers, persistent headaches, substance abuse, and an inability to concentrate at work. Hopefully this video has given you a better understanding of the stress response and its various stages, as well as some of the negative health effects of prolonged stress. Thanks for listening.